manner. So do it. Doing it is engineering. If you don't do, it is a science. If you don't do, it is a science, right? So why the learned L is put in red color? Normally, two-wheeler riding or four-wheeler driving, learner puts elbow at the front as well as back, right? Once they learn and get the license, what do? They remove it. So like that, the elbow is put in you. That is, you are the first year student. So you are a learner, L. Once you complete your 4 years of degree and get enough knowledge and enough skill to get employed elsewhere, the L board can be removed. So what's remaining there? Once you can able to remove the L, you will become earner. You can earn something. You have the capability to do it. So you should upgrade yourself, develop yourself, get more knowledge, get more skill. Every hands-on practice or hands-on is considered as a skill. In your field, programming is a skill. What is programming? Writing the sequential coding. Writing the sequential coding. That is programming. That is a skill. And the data visualization, another skill. Because it is not one graph to visualize. There are many graphs. If you go to the statistical analysis, you come across so many types of analysis. Right? So, your part is very, very important for every industry. So, you got plenty of opportunities nowadays. So, but don't miss any opportunity, because every year thousands and lakhs of engineers are coming out. So, if you equip yourself to a higher level, definitely you will get better opportunity. So, with a great mindset into study, with the hands-on practice to the engineering subject, you will progress better. Why I insist on these two again and again? Because this subject needs that. Without this subject you cannot learn. Without setting your mind, without focusing on the subject, without the hands-on practice, you cannot progress in this. If you do it, it is very easy, it is nothing. Another very important thing is, any skill you learn anytime, you will never forget. I will tell you one skill, swimming. Do you know swimming? If you know swimming, even though you don't swim for next 10 or 15 years, after sometimes there is a necessity to swim, you will do it. You will not forget. Once you know swimming, that the skill is known to you, definitely you will do it whenever it is required. Similarly, once you learn this skill, engineering graphics, it will be with you. Whenever it is required, you will be using it automatically. You will never forget. You will never forget, but learn in the right way it is expected to do. What is the right way? Learn, understand, apply. Learning here, right? Understanding up to you too. Practice, apply, go to the laboratory or drawing hall and do it. That is what I insisted them. It is not just 1 hour of lecture, there should be a practice, small practice. You should not forget this. Okay. Here a drawing is given, of course a rectangle. Another side, same rectangle but with measurements. What is it called? Engineering drawing. So whenever someone calls something as engineering drawing, just understand it is a drawing with the measurements. What are the measurements? Length, breadth, thickness, diameter and so on. Right? That's all. Right. Then we call this is a language for engineers. In the first slide I have put, what is it? Simplified approach to learn language of engineers. Simplified approach to learn language of engineers. So it is called a language. Why? So you know natural languages. What are the natural languages you know? English everyone knows. Then Tamil or Telugu or Malayalam or Hindi. Like that many languages we know. Right? So how do you say there are languages? Communication purpose. It creates some sound. You create some sound. Oscillate it. It is coming as a beautiful script, or you can hear something and understand something, right? So, but you get a script. How the scripts? Alphabets, right? Alphabets in all the languages. But when I come to drawing method, I say all the languages are having common script. All the languages are having common script. What is that, the common script? You look at every language, all the alphabets are created using points, lines, curves. Point, line, curve are the alphabets of any language. So drawing also having only that. Do you have any other alphabet other than point, line, curve? Any language, you just look at the script. No. So drawing is using again the three alphabets, and we just create meaning for the drawing. Right. So if you don't understand, take a small example. Can you read this drawing? Everyone knows it is a line, but perfectly you say it is a straight line. It is a straight line. Then suppose you draw something like this. What is it? You call it a curve, but I call it as a curved line. I call it as a curved line, right? So we just learn the straight line. What is the second one? Another straight line. I put another line just connecting the midpoints here. Third horizontal line. Can you read the three lines together? Can you read the three lines together? A. Right. A line, another line. Can you read the three lines together? Yeah. Can you read these two together? Left to right we read, it is and. Read this line. Again the same thing, right? Now read it. Triangle. There you said A, here you say triangle. Right? Again 4 lines are here. Read it. Rectangle. I put another line here. 2 squares or 2 rectangles. 2 squares or rectangles. Whatever it is. Right. Can you read these two together? Can you read these two together? You do not know the grammar. This is what engineering graphics grammar. I am going to tell you that only. We are going to study only this in this subject. How to read a drawing, how to prepare a drawing. That is the language for engineers. It is like other natural language. Reading the content in a language and writing. Reading, writing. But here we don't say write, it is draw. Instead of writing we say draw. Drawing, create it. And available drawing, read the information. Read the information. First one, even though I put 3 lines, you read it as triangle. The 4 lines, you read it as rectangle. And again I put another line, you said 2 squares or 2 rectangles. You know that extent, right? I am going to tell you one more new thing, combining the two drawings, how to read it. Actually, this is a drawing, a sample drawing in engineering graphics, representing an object. That object looks like this. It looks like a triangular plate. It looks like a triangular plate, or the shape of the sandwich available in the canteen. Right? You understand the shape. Once you see the three-dimensional drawing, you should also visualize how the shape look like. Now, look at this from here. I consider this is front. So the view, there is the front view. What is the shape you get? Triangle. That is what I have drawn there. Similarly, you look at this from top. Even though this surface sloped, it looks like a square or rectangle. Similarly, the other side looks like a square or rectangle. So once you look at this, If you know the rule in engineering graphics, you will read it as a triangular plate. In order to make you to understand how this drawing look like, another drawing is given. So this is a 3D representation. This is the 2D representation. This is called orthographic projection. Orthographic projection. And this is called isometric projection. That is one method. This is another method. What is that method? Orthographic projection. Orthographic projection is a method to draw the drawings of any object by looking at the object just by standing in front of it. There is no compulsion, you have to stand always in front of it. No, you can go to the top and see the object. You can go to the left side and see the object. Go to the right side and see the object. Go to the back of the object, see the object. And go to the bottom of the object, see that. So there are 6 primary directions you can look at. There are 6 primary directions you are looking at. Right? Whatever shape and size you see in that direction, just do it. This is what you are this is what you are going to discuss. What are the objects? What are the objects? In engineering graphics, what are the objects? In engineering graphics, we discuss only geometrical objects. We discuss regular geometrical objects. What are the geometrical objects? The smallest geometrical object is a point. Smallest geometrical object is a point. Is there any dimension to that? No dimension. Low, length, breadth, height, anything. It is only a dot. Second object is a line, a straight line. It has only a length. One end is considered as a point, another end is considered as another point. It has only length. The third object is a plane, length and breadth. There are many shapes. The plane has got many shapes. The next object is a solid. Solid and geometrical solid. What are the geometrical solids normally we come across? We come across cube, tetrahedron, octahedron, all sorts of prisms, all sorts of pyramids and so on. The regular objects. These are the objects we are going to discuss. Why these objects? Why not something else? Yes, there are some irregular shaped objects also we come across. Why irregular shaped objects? You take any object in any branch of engineering, any product in any branch of engineering, it has got a shape. The solid object only. This is what is it? Of course, remote control you can say. What is the shape? Not exactly like a prism, not exactly like a cylinder, but combination of many. A particular shape is given. Why this shape? Comfortable to hold it in the hand and operate. And the switches are provided. So you just keep the switch on, off, or direction, whatever it is. How the switch is working? There is a mechanism for that. You press the switch, goes down. When you take out, the switch comes up. What is there inside? There must be a spring to make it out. Or the material should be of the type. Like it will bouncing back, regaining the shape again. They are called a smart material. What I try to say is, everywhere any object is given that has got a shape and size. Second thing, it has got some material, whatever branch it is, right? So once you study this, you will be in a position to understand all these things much better than others. It's something like at school, to learn English, they taught you something like A for apple, B for ball, and so on. But what is the use of that? If you look at that, what is there? Nothing. But once you get that skill, applying that in your engineering learning is much easier. You are progressing from first standard to 12th standard to learn the language. Similarly, learn this graphic language in a better way, like A for apple, that is what shown here. in orthographic projection by showing the projections of a point, then projections of a line, projections of a plane, projections of a solid, and so on. And so on. This is one concept. When you draw the top view, front view, side view, everyone will not understand. Understanding will be difficult. Understanding easier only for the 3D objects. 3D objects understanding is easy for everyone. Everyone, it is quite easy. So you should also learn the method of preparing the 3D drawing. That is called isometric drawing, right? There is another method called oblique projection. There is another method called perspective projections. There are three methods commonly available to prepare the drawing, 3D drawing. So you can use any one of these three. So normally isometric is used, oblique is not that much used. Perspective projection is used by architects and civil engineers. An example, when you travel, you see a large banner showing the shape of the building being constructed there. So they take an important point as the reference. From there, if you should look at the object, how does it look like? So they put everything on that board. So that is a perspective drawing. That is a perspective drawing. Okay. So now understand one method, orthographic projection. That means place the object, look at the object from front, look at the object from top, look at the object from side, look at the object from rear, and look at the object from bottom, and so on. Okay. So we are preparing engineering drawing, but nowadays these drawings are prepared using graphics. Graphics use the computer graphics. You are studying data science, it is related to computer graphics. And your syllabus has a plane geometry where the curves are generated and there are some definitions. There are many curves. How to draw those curves? Normally you will be getting some intersection points. All those points are connected by drawing a smooth curved line. Smooth curved line. The procedure, whatever the teacher says, the same thing you have to follow. Nothing new, nothing difficult. You should know the method means you should know the method. So, conic sections probably you will be having in the syllabus. You have generated ellipse, parabola, hyperbola, right? Can you give the definition of this conic section? Can you tell me the definition for this conic section? A cone cut by a plane. When you cut something, something will be removed. When you cut a cone, what will happen? One portion removed. What will be the shape you observe? It may be a circle, it may be a parabola, it may be a hyperbola, it may be an ellipse. Right? Depending on the direction, angle in which it cut, the shape will be different. But there is a definition combining all these things. Do you get a triangle by cutting a cone? Will you get a triangle by cutting a cone? You have to visualize how the cone look like. When you cut parallel to the base, the cut portion look like a circle. When you cut the cut portion, the cutting plane inclined to the base or inclined to the axis, it is a parabola. Sorry, it is an ellipse. When it is inclined but cuts the base, again it is a parabola or hyperbola. Parabola or hyperbola. Will you get a triangle? Just to think and say. By cutting a cone, will you get a triangle? Everybody say yes. If you say no, you are not at all visualizing in the right way it is expected. True. What he says is 100% true. Equal parts. He means passing through the apex. Passing through the top point, apex, you just cut. Whether you vertically cut or little inclined, it will be a triangle only. So why I say this? If you visualize in a better way, you will get the right answer. Don't think that something is possible, impossible, just like that. You think and say. Think and say means conclude your answer with some solid evidence. You with your visualization or with the data, you have to say yes or no. You are studying computer science, data science, you say something you have to do like this. Why do you say based on this data you have to do this? Right? There is something related. The next part, after plane geometry, you study the solid geometry. Solid geometry, you come across solid objects. Every engineering has got a product. Every engineering has got a product. What is your product? You are studying data science. What is your product? I mean, mechanical, they say machine or automobile. Electrical, I say electric motor or some other switchboard or something else, electrical component. Then civil engineering, building. Electronics, you can say calculator, computer or the objects. Like the chemical engineering, the chemical powders, they are the products. Then aeronautical, aircraft is the product. All mechanical components are assembled together. Once the systems move on road, it goes very fast. When the speed increases, that mechanical system goes on air, just flying on air, moving on air. Then automobile, another mechanical component only, assembly of mechanical components moving on road, safely moving on road. Like that, what is the component or product in your branch of engineering? There is no visible product. It is only invisible product. Invisible product. It is in the form of a coding. That is what the branch name is given, data science, not engineering. Do you get it? That doesn't mean it is inferior to other or superior to others. Everything has some application. That is what I mentioned. You poke your nose into other branches of engineering and discuss with them how do they process the data. So the application is there in the other domain, right? You look at there also. You study all branches of engineering. Everywhere the opportunities are available for you. That is the beauty. Every engineering data is available. They do not know how to process the data. If you know the data science, if you know the other branch of engineering application, you will do much better than others. That's what again and again I am telling you that. Then, now I will tell you what is meant by projection. So, probably your teachers might have told you, but I will also tell you something more on this. What is the meaning of the word projection? Point will be available on the screen. The screen is nothing but a vertical plane. Screen is nothing but a vertical plane. There is no compulsion, always you have to project onto the vertical plane. You can project onto the horizontal plane also. The video projector can be installed such a way that the image can be projected onto the floor. But why it is not projected? You cannot comfortably see here. You are sitting here. I project something on this. How do you see? Battery. Why that is studied? Suppose this object, cylinder, resting like this. Where is the cylinder now? Cylinder resting on HP, horizontal plane, on one of its bases. When you read the problem, you should understand. Once you understand the parts of the solid, understand the VP-HP positions, you will tell in the right way. This cylinder resting on HP on one of its bases. Suppose I put it like this. How this solid is resting? Again the cylinder resting on HP on one of its generators. Resting on one of its generators. Generator is nothing but a line connecting a point on one end and opposite point. Right? That is what I asked you. You have studied this, your teachers must have told you, and Alexa, Look at me, man. See, whatever attitude you have to case, police will look after the previous offenders only. Why? They repeatedly do that. They never change. There is someone, a liar, never tell the truth. They repeat the same thing. There is a cheater, always get money from someone. They continue to do that. They never change. You talk here and the same habit you'll be having in the classroom also, but change. Change. If you don't change, not only spoiling yourself, you are spoiling your friends also. Because 4 years you are permitted to sit here, right? You get the opportunity to develop your knowledge. Even a generator you do not know. Without knowing this, who will give you the job of engineer? Tell me. In a simple object, you do not know what is a generator. Tell me, man. ஒரு ஜெனரேட்டர் ஒரு ஆப்ஜெக்ட்ல என்னன்னு சொல்ல தெரியலன்னா உனக்கு என்ஜினியர் யார் என்ன வேலை கொடுப்பா? உனக்கு என்ன வேலை தெரியும் engineering பத்தி? நான் சொல்றது புரியுதா? Give me the correct definition for data. What is a data? சொல்லுப்பா, டேட்டான்னா என்ன? உங்களோட பிரான்ச் தானே? டேட்டான்னா என்ன? Tell me the correct meaning. You take in the right spirit. It is not I am scolding you. It is not something I am பேசுறேன். நான் பேசுற மாதிரி எல்லாரும் கேட்கணும். What is a data, man? Collection of things, sir. Information கிடையாது. தெரியாது. டேட்டாங்கிறது அர்த்தம் தெரியாம டேட்டா சயின்ஸ்ல யாராவது ஒரு ஆரோக்கியம் வேலை கொடுப்பானா? நினைச்சு பாரு. Data is nothing but a value. Nothing but a value. I say age. Age. A-G-E. Age. What is your age? What is your age? What is your age? I collected 3 data. Age of 3 persons. So I can find the average age of the persons sitting in the first year computer science class. One information. One information. There is no compulsion. Only 17 years or 18 years old students should study in the first year. Even someone with 20 years also can study. The maximum age is 21. Do you know? First is eligibility to get admission. Up to 21 years you can take admission. They might have studied some diploma course or another degree discontinued and joined first year. Someone might have studied mechanical engineering for 2 years, then saying that don't want to continue in that college, that branch, you come to new college and take admission, and their age may be 19 or 20 eligible. So you are finding an average. With that you get some information. With that information what do you do? There are many students might have discontinued elsewhere and joined here. That may be in some of the colleges. That is the information. That is the information. Data is nothing but a value, but related to a person or related to an object. Related. Then what is an object? In data science, what is an object? Tell me. In programming, what is an object? No. Data is a single value. Object will have collection of values. A person, a student, is an object. What are the data related to you? Related to the student, name, height, weight, and type of the cloth that they are using, then the habit they have, all are data related to that person. And similar to you, there is another gentleman with the same collection of data, another object, another object, another object. In medicine they say object, not the patient. They say object, collection of some data or information. So private data, public. There are many things, right? Why I say all these things? You are studying data science. There is a relation between data and this subject. Already I told you that data visualization part of this engineering graphics. But it is not something related to projections of the cylinder. Once you know this, visualizing that will be easier. That is what the meaning, right? Again, I come to the regular job. I place the object here. The top view is a circle. Front view, what is the shape you get? Rectangle. Some of you may be thinking like, sir, how do you say it is a rectangle? It looks like a curved surface. We talk about the image. How do you get the image? projecting that object. You can have a light source here and project the image onto the plane. What is the shape you get? Rectangle. Why do I show all these things? In the regular class, did they show you all these things? Then it is good. It is the right way to learn. It is the right way. You have to use the particular model. You have to understand what we do. Sir says, draw a circle, so I am doing it. You should put forward a question. Sir, why do we draw it as a circle? Why do we draw it as a rectangle? So the teacher will tell you, when you project the image, the shadow you get, image you get is a rectangle. So you are understanding. That is what I mentioned. Learn, understand, apply. Okay. Suppose it is like this, resting on HP, on one of his generators. Generator. Now you should know what is a generator. What is the front view? Circle. Top view? Rectangle. And so on. Whatever the object is, similar to this. Whatever object is, you will get the size and shape of that. So, understanding the projection, again the first quadrant is taken. First quadrant, project the front view, you get the shape. Top view, get another shape. It is not a regular shape, it is some irregular shape. Combination of prism and cylindrical shapes. Right? So it is an object. Every engineering, there is a product. That product is somewhat similar to this. I'll just to show you a small video showing how the orthographic projection is obtained. So, one video Pradeep sir.
Sir, video plan.
Wood. Not only wood. There are some glasses in between. What is the type of that glass? Plain glass or shaded one? Then what is the thickness of the glass? And what is the size of that opening? There are so many information related to that. And where is it available? Is it locally available or imported? Who is the supplier of that material? So everything matters. All these informations are embedded into the building. All the informations are embedded into the model of the building. So it is called building information modeling. So information technology, don't think it is restricted to some sort of data processing. It is also used in other branches of engineering. That is what I told you. You poke your nose into other branches of engineering. There more applications are available. Right? So I started with the projections of points like the one you are learning and closed with the building information modeling. And this is one of the small video, and I believe this is useful for you. Whatever I explained now, the same thing pictorially shown here. Here, first part of the video, just recollecting what we do, top view, front view, all those things. The second part, the problem is taken. The problem is a model, irregular shaped model. The model is viewed in animation. The model is viewed in animation. Then the top view, front view, side view are taken. Right? Remember and recall the 6 primary views of the orthographic projections. They are top view, front view, left side view, right side view, bottom view, and rear view. Normally, the top, front, and left or right side views are drawn to describe any engineering object. Draw orthographic projections of an object shown in pictorial view. Observe and understand the shape and complexity of the given object. It consists of a horizontal plate of length 100 mm and breadth 44 mm and a thickness 18 mm with a through undercut at the bottom for a depth of 9 mm. A vertical plate with a semicircular portion at the middle of the horizontal plate having a through hole of diameter 20 mm. In the horizontal plate, a hole with a diameter of 10 mm is available in front of the vertical plate. And another hole in the same diameter is available behind the vertical plate, which is partially invisible in the pictorial view. The steps to draw the front view are: to draw the orthographic projection in front view, observe the details in the front plane, which is indicated by an arrow. thickness 18 mm with the undercut depth of 9 mm. Centrally, draw a vertical plate with a thickness 12 mm on top of the horizontal plate. Mark the axis of the hole in the vertical plate and show the hole invisible by drawing dashed lines for a width of 20 mm. Mark the axis of two circular holes on the left and right side of the vertical plate and show them invisible in front view by drawing dashed lines for a width of 10 mm. The steps to draw the top view are: to draw the orthographic projection in top view, observe the details in the top plane. Draw the boundary rectangle of the horizontal plate of length 100 mm and breadth 44 mm and project the invisible undercut by drawing dashed lines. Project the axis of the two holes from front view to mark the centers in the top view and draw the two circles of diameter 10 mm. Project the thickness of the vertical plate from the front view and mark the axis of the hole in the top view. Since the hole is invisible in the top view, it is shown using dashed lines for a width of 20 mm. The steps to draw the right side view are: to draw the orthographic projection in the right side view, observe the details in the front plane. Draw the horizontal plate of width of 44 mm and thickness 18 mm, and the vertical plate is drawn straight for 22 mm, and thereafter draw a semicircle with a radius of 22 mm. The undercut at the bottom of the horizontal plate is projected and is invisible in the side view, which is shown using dashed lines. Mark the center of the hole and draw a circle of diameter 20 mm in the vertical plate in the side view. Mark the axis and draw the two holes in the horizontal plate which are invisible and are coinciding in the side view. And it is drawn using dashed lines for a width of 10 mm. Learning is center stage. So our business start with that point. Start with that point. With reference to VPHP, here a point is located. It is above HP in front of VP. Yeah. The distances are given. It is 20 mm above HP, 30 mm in front of VP. To support your visualization, the object is shown in three-dimensional with reference to the two planes. Once you understand how the front view projected, it will be available 20 mm above XY and the top view available on HP and it is rotated down, so it goes below XY for 30 mm. Once you visualize that, go to the drawing, draw the XY line, draw A dash at a distance 20 mm, draw A at a distance 30 mm below XY, right? That is what the understanding. The next object, it is a straight line. The straight line can be kept in different positions with reference to the reference planes. How many positions? I can place the straight line. Excuse me. It is a straight line. The pen or pencil is the straight line. You place the pen or pencil this manner. It is the line kept perpendicular to HP or parallel to VP. It is a line kept perpendicular to HP or parallel to VP. Suppose it is kept like this. It is kept perpendicular to VP, parallel to HP. Suppose it is kept this manner. It is parallel to HP and parallel to VP. So what you do, after understanding the position, visualizing it, you have to say. Need not to by heart anything, don't do that. Suppose it is kept this manner, it is inclined to HP, parallel to VP. Suppose it is kept like this, same manner. Suppose it is kept in this manner, inclined to VP parallel to HP. And this also inclined to VP parallel to HP. Suppose kept like this, inclined to both the planes. There are 6 possible positions. There are 6 possible positions in which a line can be placed. So you have to understand. Then understand what is the shape and size of the line in the front and top view. Suppose it is kept vertically. What will be the front view? Vertical line. Vertical line. Top view? Point. Suppose it is kept horizontally. Top view is a line, front view is a point. Suppose it is kept horizontally this manner. Front view is a line, top view is also a line. So like this you visualize. Suppose it is kept like this, inclined line. Front view and inclined line, top view smaller than true length. True length is the length of the line and parallel to XY because it is parallel to VP. Similarly, when it is kept like this, top view is an inclined line, front view is a horizontal line smaller than true length. So we understand what will be the shape and size. If you have any doubt, again take a light source. Take your mobile light, take it from top and take it from front, you get a line. And try to understand some of the ways. So for this, I suggest you to use the models. Use the models. Models, it is a model. Similarly, for planes, projections of planes, you have got models. So I have got some models. I use it in regular class as well as even for my own understanding. So these are all the planes. Octagonal, plate or plane. It is a hexagonal, plane or plate, another model. Circular plane or plate, another model. After reading the question, to understand that, you can use the model and visualize with reference to 2 planes. For the first quadrant understanding, you can use your notebook also in the open position showing horizontal and vertical plane. First quadrant, horizontal plane, vertical plane are understood by having the notebook like this. Then just hold it and place the object with reference to this. Place it. Right? Whether it is resting on HP, on its base, or on and off its generators, whatever it is, try to understand with the help of this. But don't do anything without understanding. Doing anything without understanding is danger. Doing something without understanding is danger. I'll tell him something. This will put your finger inside the hole. You put it. Why? Why? It is danger. Okay. It is danger. Because electric current is available, he knows it. So putting finger, if it is a child, 1 year old, 2 years old child, you tell the child to put the finger inside, it will put because it does not know. Right? You know it. Similar to this knowledge, know everything, understand everything, get the knowledge and do it. In engineering, doing anything without knowledge is danger. It is a danger not only for you, for everyone in and around you. Nearby or machine. Sometimes you operate in a machine without understanding. It is a danger. You will spoil the machine. So much money is wasted. There is no employer in this world to give you the opportunity. No employer in this world to give you the opportunity to damage his machine. Right? They buy the machine investing about crore rupee or more, thousands of rupees. They never permit you to operate without the knowledge. Right? So understand, knowledge is the one take you to the next level. Skill is the one take you to the next level. Knowledge plus skill will make you as a complete engineer. Okay? We will go to the practice class and continue. And just I will show you a few more slides. Here a line is kept. Whatever question I have told you, the same thing. Line kept perpendicular to HP, parallel to VP. How the 2 drawings look like. And the right side one is the one we draw. And this is another position, another position, another position, another position. All the positions I have demonstrated now. And again, the trace of a line. What is the trace of a line? Trace of a line. trace of a line. Trace of a line. சுத்திட்டே இருக்கீங்க, இதை ஒன்று சொல்ல. Should I do in return to that? He pays you something. எதுக்கு உங்க அப்பா பணம் கட்டணும்? இதை பாரு, எதுக்கு பணம் கட்டணும்? ஏதோ அப்பாவுக்கு பிள்ளையா இருக்கிறாங்கிறதுக்காக பணத்தை கட்டுறாரு. நீ படிப்பேங்கிறக்க நீங்க உட்காந்து சிரிச்சுட்டு இருந்தா சிரிக்கலாம். சிரிக்க வேண்டிய டைம்ல சிரிக்கலாம். அதுக்காக சிரிக்க கூடாதுன்னு சொல்லல. எப்பவுமே சிரிச்சுட்டு இருந்தா அர்த்தமே வேற. Okay. Trace of a line. It is simple. Point of intersection of a line with the reference plane. Point of intersection of a line with the reference line. அது ஒண்ணும் இல்ல. If we extend a line, it will intersect with the VP or HP. If it intersects with the HP, that is horizontal trace. Intersect with the VP, vertical trace. If it is not at all intersecting, depending on the position parallel, then no trace. No trace, no VT or no HT. So with the understanding, you will learn. The same position, again few problems are shown. Right. Then understand, we come across a few lines while drawing. What are those lines? Continuous thick line, continuous thin line, dashed line, chain line. These are the 4 lines we come across, and the application of these lines, continuous thick line to show the object. Whatever object you draw, show the object alone darker. And the construction line, thin line, then chain line, imaginary line, dashed line, invisible edges, and whatever you write based on the shape of the alphabets given here, you have to, don't write in running handwriting or cursive writing. You should print the letters separately in the shapes provided here, not all the shapes. So these are some of the applications. Even with this knowledge, drawing knowledge, there can be a big industry to manufacture. There are many industries. They operate with the knowledge of engineering graphics. One of the applications are drawing up, developing surfaces in the sheet metal workshop. It is a mechanical application to generate objects from the sheet metal. Then again, other applications in most of the other branches. And last one, computer design, and the third from last, application of computer graphics, mostly in game design, video game design. The graphics is applied. Then you come across computer graphics. Computer graphics, you study mainly the 3rd year or final year. What do you study there? For the mathematical coordinates, how to get the graphics and how to get the graphics moving. Moving, it is an animation. For animation, we do some kind of transformations. What is a transformation? Regenerating the graphics in a new location. So that is called a translation. Relocate, again generating with the shape tilted, it is called rotation. Then reduce as the object moves beyond, backwards, you reduce the size. When the object moving in front of you, increase the sizes. So it is called scaling. So we can do some sort of transformations like translation, rotation, scaling. All these things you study in computer graphics, in mathematics, and again in graphics, and the application of that is this engineering graphics. Okay, to understand that subject and video game design and other graphic design in computer design model or building information model. Model means it is a graphical 3D object. Now, almost all the places, the regular engineering graphics is replaced in the other way. It is generated in 3D and the 2D is generated from there. So that is the trend now. Whatever you study here, if you study in the perfect manner, in the future semester you can apply. So wish you all the best, and every study you have to take it very sincere and do it in the way it is expected. Every day you have to study at least 3 to 4 hours. Every day you have to study at least 3 to 4 hours. If you are unable to do on regular days, you do it on Saturday or Sunday, but don't reduce. Keep reading, keep learning. At one stage you will get the good knowledge expected by the industry and you will become employable. That's very important. That is the ultimate expectation from your parents as well as from the institution. So wish you all the best. We will continue the class in a practice session. There I will give you 1 or 2 problems. You are supposed to draw it. Just I would like to see what way you draw.
Okay.